So let's keep cooking with our in-class discussion stuff. So last time we were starting to talk about the idea of like a general network organization from a multiplexing, demultiplexing perspective, when you have a whole bunch of connections that you want to broadcast to like we talked about it from like a cable modem perspective, or from a cable TV perspective. You want to broadcast all the cable TV to a certain neighborhood. Well, your TV company doesn't run 100 lines for 100 different channels to the neighborhood, or you can think of it, they don't run 100 different lines for 100 different houses from the home office to those houses in the neighborhood. Instead, they run one line to the neighborhood, multiplex the signal over that line, and then break it out into the individual houses from there by demultiplexing it, or some variant on that technology. So that would be the older baseline technology. And then the ways we might accomplish multiplexing and demultiplexing has evolved over the years in terms of the software that allows us to do that with compression and things like that. But that concept of taking a bunch of channels down to one channel, multiplexing, and then taking a one channel and splitting it back into a bunch of channels, demultiplexing, remains the same. All right, so we talked about kind of the difference between bandwidth and latency, and why somebody would want fast internet. For example, what does fast internet mean? We talked about now that we have all of our devices all connected to the network, we can't just view it through a single user or a single application use on the internet. Inside our house, we might have 10 or 15 different devices that are all vying for the internet, and maybe these devices in general don't take up a whole lot of bandwidth. Each one takes up some bandwidth, and that ultimately adds up, and that's why we need reasonably fast internet connections to support all of our devices. So why buy faster than the lowest end internet? Well, you might decide that, okay, well, I may be doing stuff on my network that takes additional bandwidth. Maybe you're doing extra video streaming or things like that, or you're doing a lot of downloading. Or you might say, oh, I just have a family of 6, so we have more users who are all doing their own thing, and we're all vying for the same bandwidth. So you can think of the bandwidth as kind of like your water source. You only have so much water coming to the house, and if everybody's trying to take a shower at the same time, you're gonna have some issues. People aren't gonna have a whole lot of water pressure. So that's kind of the idea. When we think about bandwidth. So I want to talk about this idea of a modem to start off with today. So I'll actually go ahead and get rid of this right now. This is just a reminder for me. Anybody know what modem stands for?
Modulation and demodulation.
Yep. Modulator, demodulator.
It connects the phone.
What does this do?
Home, like cable connection.
Well, so what does a modem actually do? So it stands for modulator, demodulator. So now the question is what is modulation? What is demodulation? Similar to what's multiplexing and demultiplexing. So what are these terms? What does a modem actually accomplish? When we first introduced the idea of modems, and if we want to think about it from an internet connection perspective, because technically modems lived before that, when you weren't actually connecting to what we would consider the internet. We were talking to a bulletin board system or something like that. We'll probably mention that here in a few minutes, but typically these guys were used to interface a digital computer to another digital computer over what kind of medium? What was the cable between the two computers? over a telephone line. So this is something called POTS. Anybody know what POTS means? Plain old telephone service. All right, so our POTS network is our plain old telephone service network. Now, what's interesting is, now it does still exist, but my guess is, does anybody in class today, does anybody actually have a wired telephone line in their apartment, or does everybody just use cell phones? Does anybody here have a hard line telephone line?
No.
Nope, nobody, right?
Yeah.
Have any of you ever had a hard line telephone line?
Yes,
Is it common in India?
it was common, but now it's mobile phone.
Okay, yeah. So when I was a kid, everybody had a telephone line. That was the only option. We didn't have cell phones, right? And over the years, and then there was this transition period where, yeah, you had cell phones, but you always had at least one telephone line at the house. You had your home phone. If you see that left over when you're filling out forms online and stuff, sometimes it'll ask you for your phone number, and it'll ask you for your home phone number and your mobile. Have you seen that on forms? And you kind of put down the same number for both because, well, that's my phone. If you want to call me, that's what you call. Well, home phone really meant your landline at your house. That's what that guy meant. But that's becoming less and less common. I don't have a hardline telephone line at my house. Some people, I would say the common use for hardline telephone lines at people's houses currently or in office buildings might be for fax machines. So even though those are falling out of favor, people aren't really using fax machines nearly as much as they used to. You still do have some scenarios with contracts and medical documents and things like that some places still require it to be faxed rather than sent over as a PDF or something, but those are even disappearing now. So it's going to become even rarer and rarer to have a hardline telephone line at your house. But they do sort of kind of exist today, but not very commonly. All right, so with that in mind, a modem was a piece of equipment that interfaced your computer to another computer over a telephone line. So a plain old telephone line is not digital, or at least we weren't using it for a digital signal before. We were using it for a analog signal. Analog versus digital. So digital is discrete zeros and ones. Nothing measurable in between. Analog has multiple measurements between 0 and 1. Looks like a wave. So we could probably just see I'll just do a digital versus analog here. We'll probably get a picture that shows the comparison of those guys. Here we go. So here's an analog signal. There's a digital signal. We'll just steal that guy real quick. Get it into the slides. All right, so that's what we're dealing with here. Let me make sure I let that person in. All right, so now our computers talk like this. digital signals, zeros and ones. So if we are communicating over a digital line, okay, so if the wire going between our those two computers, let's say, is transmitting data in digital format, then we don't need to do any translation, right? If it's moving along this wire as zeros and ones, then the computer on either side can already understand it. But if it's moving along that wire as, values that are all over the place, where, this guy might be a 1, anything kind of up above this line, this might be a 0, anything below this line, but there's ranges here that kind of need to be interpreted into the actual zeros and ones. All right, that makes some sense. So I'm going to actually switch the order of these slides. So what does a modem do? A modem converts the digital signal from computer A into a analog signal to send over the telephone line, and then the modem on the other end converts the analog signal back to digital for computer B. So if we want to see a picture of that, actually, I bet you we can probably get a real quick picture online. You'll have 2 computers, 2 modems, and the connection before. Modem connection between 2 computers. See if we have some of these are okay, but I don't really like I don't want to have overly complicated ones. Yeah, I'm just going to draw it. So in our example here, we have computer A. We have computer B. We have a modem that's connected to both of those guys that acts as our interpreter. And then we have our telephone. We have that guy. Okay, so this is the communication channel that these 2 computers are sending data over. And those modems are doing the interpretation between digital to analog and from analog back to digital, modulating and demodulating. All right, that makes sense? Anybody in here ever use a dial-up modem?
Used to long time ago.
Okay, so you have before?
Yes, in school days.
Okay. So when you connected with so when you dialed up to your source, so a lot of times the way this would work, I'll just draw another picture. In the early days of modems, we would have a server and initially, this is before the internet, the server might have been called a BBS, a bulletin board system. All right. And what a bulletin board system did is it gave you effectively before the internet existed, before we had all of these tools like web browsers and things like that, that allowed us to use the internet. And we had all these different service providers out there. You know, you could go to Nike's website and Mercedes-Benz's website. Before you had all these different places that were putting content out there, the predecessor to that was having a single computer that had some entertainment kind of stuff on it that multiple people would connect to. And these were called BBSs. So you might connect to one of these things and it would be all text-based. Let's see, what is this guy giving us? Yeah, so here's like an example. When you first connect to one of these guys, notice it's kind of saying, hey, you want to go here to read news. Here's some entertainment stuff, recreation. There might be some games in here. Some of the early games were called MUDs, multi-user dungeons, all text-based, nothing graphical. So this was like the predecessor to the internet, where we still had different people on different computers connected together into a central world, but that entire world was housed inside of this BBS, this guy right here. All right, anybody in here ever use a BBS?
No, no, sir.
So we lost the crowd there. You've probably heard of some early BBSs, the popular brand. So once BBSs became kind of popular, when people, more and more people had computers with modems, you probably did hear of a popular BBS that had graphics associated with it called AOL. So if you kind of look at this, doesn't this look pretty similar to what we were just seeing, but this is graphical? You have news, you have sports, you have entertainment, you have games. So this is a person's home computer connecting to a modem up here. But they probably, what they had is they had a bank of modems. So they had a bunch of modems that were all sitting behind the same phone number. So I'll call that like a line mapper. So you would dial in to this line mapper, which would then route your modem to whichever of their modems is currently not busy. All right, so they might have 30 modems, let's say, but the problem is if 30 people were connected all at the same time, there was no modem to take your call, because the two modems needed to be in constant contact with each other in order for this to work. So you would dial into a central hub with a single phone number, which would then hand you off to one of the modems that's not currently being used. And then that would connect you to that server. And then those two modems were the ones talking to each other until they hung up. Okay, so you were using that that line. All right. Now, what ended up happening? So how did this evolve? This eventually evolved where, this bulletin board system ended up not being your your destination. Instead, it ended up being a computer that lived on the internet. Actually, I'm going to use the one with an arrow on it. To the internet. All right, so eventually these bulletin board systems would add a one of their features would have been like www, World Wide Web. And that would have given them an on-ramp to the internet where they could start talking to other computers that were hosting websites using the HTTP protocol. And we'll talk about that kind of stuff as we continue to evolve this. Okay. So this is kind of the history of how our internet came to be. We started off having just our home computers. Then we wanted our home computers to talk to other computers. So we had to say, well, how do we talk to each other? Well, you could network them directly together using, various network technologies. In the early days, maybe it was like Token Ring or ArcNet, something like that. But hey, what if I want to talk to another computer that's not in my house? Maybe it's across town, or maybe it's 2 cities over, maybe it's a state over, so on and so forth. It kept getting farther and farther, but something that we didn't have a convenient direct cable that we ran from one computer to another across the living room floor or something like that. That's where we started having these modems. We said, okay, well, we need this guy to interpret our digital signal to an analog signal, because we already have all of these telephone lines that are run all over the world. And we're going to go ahead and utilize those for sending data between our computers. But it just so happens at that time, we only really knew how to use those telephone lines for an analog signal. Because when you're speaking to somebody on a phone early on, it was analog only. And you've probably seen the some analog technologies before. So have any of you ever watched TV and had those antennas on top of your TV? A lot of times we call them rabbit ears. TV rabbit ear. Yeah, these guys. Any of you ever have a TV set that had something like this on top of it? It probably looked a little bit more like this, or maybe like this. Nobody ever used rabbit ears?
No.
Okay. Well, what you would have sometimes with rabbit ears is you would get a channel that was kind of snowy like this.
Yes, yeah.
Now, the thing is, you would sometimes get a partial picture. Let's see if I can get this an example of a. Yeah, here, something like this. See how he's kind of sort of getting a signal?
Yeah, yes, sir.
And he's kind of messing around with the rabbit ears to try to
Right.
dial it in, right?
Hmm.
And sometimes you'd have people, they put foil on them, it was like this whole big this thing. Well, this is evidence of an analog signal, okay? Because it's not just on or off. You can have something in the middle, right? Kind of go back to our picture here. Analog looks like this. So if our picture is made up of a bunch of zeros and ones, and we have something that's like a 0.25, and we have something that's like a negative 0.3, those are going to come in as fuzziness over an analog signal. Whereas in digital, it's either completely on or it's completely off. All right, so we wouldn't have this kind of thing over a digital signal. So if you've had either DirecTV, DirecTV is a good example because we see this happen relatively often. Any of you ever used satellite-based TV? DirecTV, Dish Network, I don't know what the companies you have back home are. But anybody ever
Yes.
used cable TV that uses satellite? Nobody? Well, maybe you're aware. What's one of the downsides to so what I'm talking about here is like if I do direct TV, you have this like satellite dish outside your house, something looks like this.
Yes, yes.
All right.
Like in India, like Tata Sky Sunrise.
So you have those kind of things, and that comes into the house into a box, direct TV box, and then that box decodes the whatever. So what's one of the big complaints people have with satellite-based TV?
Poor signal due to weather.
Yeah, weather, right? So, I mean, this guy right here, this thing on your side of your house or your roof, wherever they put it, they have to, it has to be pointed to the right part of the sky where the satellite is. The direct TV satellite is up in geosynchronous orbit in space, right? So they got to point it up to space so it can pick up that signal. Well, as long as they have a clean line of sight to that area, everything's fine. But if it's raining really hard or it's snowing,
Yeah.
you get stuff that's between your dish and that satellite, and there's a lot of space between your dish and that satellite. Space is far away. So a lot of stuff can happen between those two places, and because of that, you would get maybe a problem with your signal. But with direct TV or any of the dish-based things, there is no such thing as having that partial signal, or like, oh, I'm watching my soccer game or I'm watching my cricket match, and I can sort of see what's going on. That doesn't exist. It's either crystal clear or it's nothing, no signal, right?
Yes.
There's nothing in between. Why is that? It's because it's digital. So digital has the advantage of carrying more data, more higher quality data, because we're not having to interpret along this analog line here, but it also has the disadvantage of interference. Having problems. If we lose some bits, we've lost data. We've actually lost data. We can't just say, well, maybe the signal's a little bit weaker, but we'll figure it out. We'll just make a guess, and maybe it'll be a decent guess. All right, so something like that. So in the early days of the internet, we would have our computer would talk to this, and here, I'll just make a duplicate of this guy over here. Computer B would also talk to the line mapper, and he would get a communication with a modem. So both of these guys were talking to this modem bank, which then were connected directly into this server, so that these two computers could, these people who were running these computers could, interact with each other, like in a chat room or something like that, on this server, by way of them connecting to the server through their modem bank. Show you here. BBS modem bank. That's not what I'm looking for. Something like this, where you had a bunch of modems in here, and this is that line mapper piece of equipment where people would dial into the phone number associated with this. It would hand off to one of these modems. You still had to have a telephone line for every one of those modems. It would just kind of forward the call. So this was not a cheap thing to do, because telephone companies, they charge quite a bit of money for telephone lines. All right, but that's what was going on here in the early days of our computers wanting to talk to each other over some sort of length. All right, and our early connection was over analog lines. So we had to take the lines that were already in existence, that we've been talking over for years and years and years, and we started using them to have digital computers communicate with each other, and we needed modems to handle the translation between digital and analog. All right, that makes some sense. So a couple of you said you've used a dial-up modem before, but maybe more people have kind of know what's happening. So when you use a dial-up modem, so it dials the number and it's connecting to another modem, what happens? What do you hear?
There's some noises like a
Yeah, crazy
Yeah.
noises, right? Stuff like that, right? All right, so the crazy modem noise. All right, so these are two modems. Well, does anybody know what's happening while that crazy modem noise is going down? What is all that noise about?
This is the connecting, like the noises for the wire. Maybe it will cut. This is the signal that's sent it from the device to the another device to connect.
Oh, okay, and what are they trying to accomplish? So those are two modems talking to each other, right? And what are they trying to accomplish? So here, we'll give a name to it.
Communication.
Well, that thing's called handshaking.
Okay.
Ultimately, they want to accomplish communication. Is the process of, let's say, establishing communication between two modems in this case. But what is all that beeping and stuff? What's actually happening?
Maybe they send to each other a signal so they know this one connecting or not.
Okay.
I think it's trying to connect it is capable for both signals.
Yep.
Like,
So they are trying to figure out what is the fastest they can communicate
yeah.
with each other without making mistakes. What drives this? And we're going to talk about, so I'll just throw a little note in here. We didn't have TCP/IP yet. We'll talk about what that means, but effectively, when we get to it, TCP/IP is a way of correcting any errors that happen. We didn't have a way of correcting errors. So we needed to make sure that we communicated between those two modems at a slow enough speed that we didn't make mistakes, yet at a fast enough speed that the user was happy. So all that beeping and stuff was all about figuring out how fast can we talk without messing up. All right. So what are the things that drive this? All right. So one thing might be line noise. Over the telephone line. Being analog lines, there's interference with other telephone lines, and there could be, other things in the ground that would cause some interference. So even if the telephone line was capable of a certain thing, we'll talk about that in a second, the current state of it might not necessarily allow you to get that maximum speed. So line noise over the telephone line. Also the max speed of the slower of the two modems. So if you had two different modems, but one was we'll just say half the speed of the other one for right now. We're going to give some numbers to it here in a minute. You would, the fastest you could even potentially communicate is at the fastest speed of the slower modem, right? And then that would get further degraded by the telephone noise potentially. So as an example, let's see if I can, so we say history of modems. They did go slower than this, but we had originally had like a 300 BPS modem. I'm just going to kind of hit the high points here. We had a 4800 BPS. 9600 BPS, 14,400 BPS, or this is a 14.4 kilobits per second. 28,800 BPS, 28.8 kilobits per second. 33,600 BPS, 33.6 kilobits per second. Then you would see something called a 56K modem. So this was actually a download versus upload. So this was 56 kilobits per second download, 33.6 kilobits per second upload. It used some compression and things like that. You know, this is like when they were really trying to maximize the speed of you know, of your internet in the very early days. So if we do 56K modem, it'll probably be bring up like US robotics, something or other. Yeah, here we go. Look at that. 56K fax modem, US robotics. Yeah, I had this one. Man, awesome. I bought that at a store called Pomida. They don't exist anymore. Let's see. Let's just do modem speeds, dial-up modem speeds. Yeah, so here's kind of a drop down. So you see a lot of our things we had in here. You know, I didn't have 1200, but we had a 4800, 9600. Oh, I didn't put 19.2. 19.2 is a popular one. Actually, it wasn't. 19.2 and 38.4 were never popular. 56, you know, so you would pick your speed. If you're trying to tell it what you were doing. Let's see, what does this guy give us? Yeah, that's a pretty decent image. We'll steal that for education purposes. All right. Now, I think I had told you this maybe the first day of class, but just another warning, and I know I'm behind on grading, but I'll gonna try to get caught up on that the rest of this week. This is our first week back for undergrad too. So you know, if you're doing your homework or something like that and you need to bring in a source from, I mean, if you put an image in or something like this, that's fine. I don't necessarily care. But if you're bringing in words from somebody else, from the internet or something like that, I don't necessarily care. Just make sure you give them credit, which is then also telling me that you're being honest, that these aren't your words. These are things that, hey, I read this makes sense to me. I agree with this. Somebody else said it, and I'm going to use it as part of my, you know, part of my answer. I mean, the worst that'll happen is a teacher might say, hey, look, you're basically giving me everybody else's words. Yes, you're giving them credit, so you're not really cheating, but maybe convert it into your own words more often. But you know, make sure you make a habit of that if you are taking stuff off the internet and submitting it with your work or a test or whatever it is, you know, that you give them credit, so it at least sends the message to the teacher that you recognize that, you know, you are using somebody else's words, but it's because you agree with them. You know, why reinvent the wheel, that kind of thing. All right, but this is a pretty good picture thing here of our, you know, various modem speeds in between, and also the years that they came out. So, you know, I was sitting, oh, I'm in this range in here. So I was born in 1978. In fact, my birthday's tomorrow. If you want to make a YouTube video and send me a happy birthday song, I'll post it on Slack and it'll be hilarious.
Yeah, sure.
Sure, Dr. Megan.
A couple of my buddies, every single night this week, different friend groups are taking me out. So last night I went out with my buddy Shiva from outside of Hyderabad. Tonight I'm going out with Blade and a guy named Waleed, who's Egyptian. Blade's a Chinese guy who works in the department here. But on Monday, I went out with a couple of our former American students, and they got me this sash that says, "Birthday Princess." I had a pink hat. I have a picture. I'll put the picture up on here. I'll just do it now. I'll put it up on Slack right now if you just want to see what it looks like. So we try to have a good time in the department. All right, there we go. It's sending on Slack right now. Just let that keep sending, but it'll be up on Slack in a second. Usually pictures load faster than that, but whatever. Okay. So anyways, this is an interesting thing because it gives you dates on the side. I definitely used a 2400 modem. I definitely used a 4800. I definitely used a 96. I used all these. So basically from 2400 on, I don't recall ever using a 1200 baud. This was called a 600 baud modem. So I recall using a 20. No, this is, yeah. I recall using a 24 modem. I don't know which baud it was, but whatever. And notice here, it's the type of modulation it would use was different. That was like the technology increasing or technology changing as time went on, but you were still solving the same problem. Just like I said earlier about multiplexing, demultiplexing. Same thing's true with modulation and demodulation. You're solving the same problem. You just might have software that allows you to solve it more efficiently or whatever, that kind of stuff. All right. Yeah. So here's this bit rate stuff here I was talking about. Oh, and notice the last generation of the 56K actually it gave you an upload of 48 instead of 33.6. Again, if the line was perfectly clean, that type of thing. But this gives you a little bit of history. So notice that our dial-up modems kind of dropped off around 2000. That was right at the beginning. We were probably transitioning. You probably started seeing alternative ways of connecting to the internet pop up around the 33.6 modem time period, but it wasn't available to everybody. So kind of late-ish 90s. That's when you first started seeing cable modems and DSL pop up. And we'll talk about those here in a minute. Okay. So one of the complaints, especially as the internet kept getting bigger and bigger, let's say, as we started transitioning from text-based BBS to graphical BBS like AOL to then let's add the internet to this because now this BBS is actually connected to other computers on a larger network. That's the internet, is having all these different things connected to a whole bunch of places. So when you like from here, I'm sitting in my office at Concordia right now, and I'm hooked in through the wireless, and so my computer is connected to Concordia, which is then giving me my this is a router at Concordia, which is then giving me my access to the rest of the internet. But Concordia is actually attached to whatever place they get their bandwidth from, which then gives them access to all the other places that have pipelines going in there. And that's what the internet looks like. If we do internet network map, let's see what we get out of this. Well, that's from 1992. Well, that's actually probably not going to be a horrible one to look at. Be a little simpler back then. So in the early days of the internet, this is, these pictures aren't quite to scale. This is what the internet looked like. So these were the major hubs of the internet. So this circle right here, they're labeling as Urbana-Champaign. And the thing is that since most of you aren't from here, anybody know where Urbana-Champaign actually is? It's not here. It's more in this area right here. Urbana-Champaign. I grew up here in Urbana-Champaign. And so I was involved in some of the early parts of the internet. There was a place this is the University of Illinois at Urbana-Champaign is where this circle should be. So they took some liberties with this map, but it gives you a decent idea of what's going on here. And my mom used to take me down because, you know, we didn't have a lot of computer networks and computer labs and stuff in those early days. But there was a place at Urbana-Champaign called NCSA, National Center for Supercomputing Applications. Yeah, so this place. Okay, so my mom used to drop me off here when I was a kid. I would just stay the whole day there, and I'd go in. I have my box of floppy disks, and go in. I started programming when I was 9, so I was just the super geek kid. So NCSA Mosaic. So this software right here, this is one of the original web browsers. This is way before Netscape and all those guys. It was called Mosaic. And I was, we would call it a beta tester today. So I was this little kid that the geeks at University of Illinois would come out, and they, I wasn't that little, but I mean, I was, I guess like probably 10 or 11, 12. I don't remember the exact age, but something like that. I wasn't like a 4-year-old. But, they would say, hey, try this, because we would be launching, I would be on a Unix machine there, and we'd launch up, Mosaic, and now we could browse the internet with full graphics, which was like, completely new type of stuff. So this was, notice here, like this is some of the early, websites. This is a website in the UK, I guess, but the website itself would have all of its resources. Almost like every single website was a bulletin board system, like we're talking about here. So they were all connected to each other. So just kind of some interesting stuff that's happened, right here in the Midwest is. I mean, it would not be, here, 1993, Mosaic Webs, they probably came out with it maybe in 90, I was messing with it, 89, something in that ballpark. Oh, here's Mosaic 1.0. Let's see if we have a date on it. All right, so 93, would it have been that early? Because I wasn't in high school yet. I want to say it was maybe 1990 when I first saw Mosaic, when they were working on the software. So these were students at University of Illinois. So I would say I knew these guys, but I mean, I was the little kid they brought the software out to. It's not like I hung out with them. But yeah, so uiuc.edu. So kind of an interesting, connection to the birth of the internet that I sort of kind of have. Just get back to that previous picture. This guy. So this is in 1992. So the very early days of the internet, kind of, we probably just had a few graphical web browsers that were kind of faking it. So there were a couple of previously text-only web browsers. One was called Lynx. There were some hacks where you can get it to actually load pictures and stuff like that. But in any case, looking from the United States perspective, all of these white circles, these were effectively from our picture. If we want to think about this from our picture's perspective, every one of those white circles was a bulletin board server, was something that looked like this. They maybe didn't have access to modems. Maybe the only people that were connected to it were local computers. Like, for instance, when I was down at NCSA, I didn't dial in through a modem. I was sitting inside of a lab with, like 20 computers in it, and they were all networked together, connected directly to the server. But one way or another, you had computers hooked to this server. And in this picture here, those servers are these white dots, let's say. All right. And those white dots are then connected to each other. All right. So we would have to have some way, there was some connection between these two that was probably purchased from, telephone companies or something like that. But there was, some sort of connection that these guys had between them that allowed us to have this network, this computer network that bridged the entire country. Make some sense? And a lot of these were universities. So kind of the very early days of the internet was for moving research, like HTML. That language was originally created for kind of representing structured data for research purposes, so that somebody from University of Illinois could, send some stuff to Palo Alto, maybe one of the University of California universities, something like that. So just kind of an interesting map. So that was from 1992. I'm interested, and let's see if we can get 2020. Just want to see how much US internet network map. Just have a year on it. Well, regardless, we can see that the map has certainly expanded, right? All right, and you can see us right in here. We're in a nice sweet spot. So I know several of you live down in Chicago, so you're right here. Okay, and we have a good connection between us and Chicago up here. So we're in this zone right here. So this northeast corridor, the Midwest, the Eastern Midwest to the Northeast corridor has quite a bit of connectivity type stuff. And once you get out here, if you're ever driving out in these, people go out on road trips out here to there's a place up here called the Black Hills, and Mount Rushmore is out here, but this is like wilderness. There are cell towers and stuff like that now, but your internet connectivity out in this zone is not nearly what you want it to be. So when you think about the big cities in the United States, what are we looking at here? We're looking at Los Angeles, San Francisco, San Diego, the cities you've heard of, right? Up here we got the Seattle, Portland, Oregon, so other bigger cities. Is that Salt Lake City, Utah? And then up here, I mean, you got your Chicago, New York City, probably Boston is going to be somewhere in here. A bunch of big play. Washington DC is going to be sitting kind of maybe right in this, maybe right here actually, but somewhere in this little zone is Washington DC, so on and so forth. So our big things. Now, what might be interesting to look at here let's look at India. We're probably going to see core structures around Hyderabad, Mumbai, Delhi. Let's see if we can get a, is this like a heat map? No. I won't spend too much time on this. It's just more of an interesting thing since we were just looking at the US map. This is network. Really, number one, Metabad. I was here. I didn't like it. It's a dry state. No alcohol. And I was in Chennai. I was in Delhi. I've been in Hyderabad. A bit of Mumbai. I think I've been in Surat, but I don't recall it now. But I've been down here in Hyderabad the most number of times. And then the oh, was it really this far? Ahmedabad? Because I flew from Hyderabad to oh, I guess Hyderabad's here. So this is Telugu state, Telegali, whatever. I flew from here to here. That was like a 2-hour flight. Something like that. All right. So in any case, when we looked at those white circles, each one of those is kind of one of these bulletin board systems, and that's kind of how the internet is put together. So we talk about DSL versus cable modem. I'm just going to create a separate slide for that. Time here. Well, actually, let's just do faster than dial-up internet. So let's start with DSL. This is a digital subscriber line. This guy used the POTS network to send digital signals rather than analog signals. Cable modem use the existing coaxial network used by cable TV companies to connect consumer computers to the internet. All right. So now right off the bat here, what should be something that's jumping out is, if you had, any of you ever have DSL or have DSL now? If your internet is from like AT&T or Verizon down in Chicago it'd be Verizon, up here it'd be AT&T, then you have DSL. But this would have a DSL modem along with a filter that connected to the telephone line before it connected to the modem. So we're going to be closing some gaps here. So we're just going to talk about DSL here for a second. All right. So if we look at a DSL modem, let's see if we can. This guy right here. All right, so you plug in the phone line here, And then you plug this into your modem, your DSL modem. Okay. Now, I go on the next page here. DSL filter. Draw this as pictures. So that's our POTS telephone line. All right. And then on this end, we have our DSL modem. And then we had to have a filter before it got into the DSL modem. And we'll just say that over here is the internet. So in this example, we don't need to think about what's over here. It's just the rest of the internet, let's say. So this is your ramp onto the internet. Now, what's interesting here is that DSL stands for digital subscriber lines. Remind me, what does a modem do again? Remember, modem stands for modulator, demodulator. What does modulation and demodulation do?
Like converting analog to digital and digital to analog.
Yep. So converting analog to digital and digital to analog. Okay. That was the purpose of a modem. DSL is a digital subscriber line. So with DSL, the signal sent over POTS was digital. Now, and we'll come back to this filter thing in a second. If this signal was digital and your computer, I'll steal computer A here. And your computer is digital. Do I need a modem?
No,
So why do they call it a modem? This is digital here. This is digital here. The purpose of a modem is to convert from digital to analog. I don't have any analog. Why do they call this a modem? The answer is pretty trivial. Go ahead.
Digital data to analog signals for a phone line.
They use it for different purpose. Like the company, when they send, they allow you to get the internet or no, maybe, or something like that.
That's actually not a bad suggestion. That wasn't how what they did, because that's what this filter allowed you to do. It would allow you to pull it apart. But the reason they kept calling them modems is because people associated connecting to the internet with the word modem. I mean, do you think Grandpa knew what a modem did? Did Grandpa know that it was translating from digital to analog and back? Or did Grandpa just think that, oh, the dial-up modem thingy is what I do to get to the internet? So when they start wanting to sell you DSL modems, you know, like the modem, oh, that's the thing I need to connect to the internet, because that's modems are what we need to connect to the internet. It was a marketing thing. So they kept calling them modems, even though it was not functioning as a modem. Most of them function as routers, at least modernly they do. Okay. So now let's get to this filter. I'm telling you that this was actually a digital signal that was being sent over that copper line. So now, and up to this point, we know telephone is traveling over these same lines, right? So back in those days, we had two different signals, at least. But let's just say in our example here, we had two different signals on this single line. Using that same phone line, I could make phone calls, but I could also get internet using DSL. So that means that one way or another, two separate signals had to be combined to travel over a single line. Do we know of anything that knows how to do that? What allows us to take multiple signals and turn it into a package that can travel along a single cable? Where's our... This guy? Multiplexing, demultiplexing,
Yes.
right? So we had a telephone signal, which is analog. We had a internet signal, DSL signal, which is digital. We need those two guys to come together and travel over the same piece of copper. Because this line right here, I mean, we can call this a plain old telephone service network, but this is just a copper wire. That's what telephone line is. Okay, it's a couple copper wires, but you know, you get the point. So this is a single cable that now has two signals on it. And this filter, we only put that filter before our DSL modem. Acts as a demultiplexer to take the digital channel off the HOTS line and feed it to the DSL modem. Draw a line. That makes sense? So now we're starting to see some of those things in action. You know, we're saying, oh, well, okay, that we didn't have a practical use for a multiplexer and a demultiplexer before. We just kind of talked about it at the high level. But now somebody put that internet, the digital connection and this analog connection over the same line, and we need to have a way of peeling them back apart. That's what this filter did. This filter gave us just the digital signal that fed into the DSL modem that did not have to be modulated or demodulated because it's already digital. You know, now maybe this modem did some decrypting or something like that. So, you know, something that, did require a computer box type thing in order to accomplish, but it certainly wasn't modulating and demodulating analog to digital and vice versa. Okay, but we call it a modem because that's what people expected you needed to connect to the internet. All right, and then this guy would plug into your computer, usually through like an Ethernet cable to a network card in your computer, whereas cable modems typically plugged into your, dial-up modems plugged in through a serial port on your computer. Doesn't really matter one way or another. It's coming into an I/O port of your computer that is able to retrieve a signal, and then the software inside your computer is going to handle the rest of it. It's going to convert it into something that's usable. All right. So does this kind of make sense how DSL worked? So DSL was really kind of our like next logical step. You know, if you think about how human beings typically work, you know, we try to keep making what we have better and better and better and better until we just kind of hit a wall. like, okay, we just can't squeeze any more out of this. And that's when we need to start looking at alternative technologies. Okay, but we know DSL still exists today. You know, if you're up in this area and you buy your internet from AT&T, unless you're in downtown Milwaukee, which has their fiber for gigabit internet, majority of AT&T's internet service up here is DSL. So if I do AT&T DSL, let's just do AT&T internet. You're going to see that the speeds are pretty low. That has to be using fiber. Okay, yeah, so these are all fiber internet connections. We're going to see speeds like 24 megabit per second. Well, here's the university. What? Oh, I see. All right, hold on. Let me put my address in. All right, so this is what I was looking for. So first of all, notice that where I live, which is not in the boonies, right? I mean, I live 7 minutes from campus in, you know, a city. I have fast cable modem where I'm at. You know, I can get speeds up to 25 megabits per second. Now we know that that is a maximum download speed of 3.125 megabytes per second. And I think we saw yesterday that that would barely, in fact, I don't think that would get me 4K, right? Or just it's right on the cusp of Netflix single user 4K. So this internet connection, while it would be sufficient for, you know, most things, it is right on the cusp of almost not usable for all the things I might want to do with it. Yet it's the only connection available to me from AT&T in Grafton. Why is that? It's because sending that digital signal over a telephone line has a limitation. It used to be called the final mile. Once you were further than 1 mile from the telephone company, the digital signal lost strength and would no longer work. All right, that then became kind of like the final 3 miles, the final 5 miles. So they fixed this with something called a remote DSLAM, which you can kind of think of as like a repeater. So they would put these pieces of equipment out, 1 mile apart, let's say, on their network, and it would effectively pretend to be a telephone station and revitalize that signal so that it could ultimately reach houses that were farther away. Okay, and the further you were away from the home office, that slower that maximum speed would drop off. Is what would happen. All right. So max speed of DSL is in the 25 to 50 megabits per second range. And I'm really being pretty generous there with the 50. I mean, the 50, you basically need to like live next to the telephone company. So generally speaking, 25 is about where we've stretched it to in order to have a signal. Now, we saw the other day that the budget pleaser starting rate for Spectrum, which is cable modem, was 200, 8 times the speed for a pretty similar price. So 25 megabits, I would get $55 a month. Spectrum internet cost. $200 megabits per second. This comes with TV. Here's just the internet, $50. And it probably goes up a little bit. You probably has like an introductory, whatever, but let's call them similarly priced. So I get 8 times the speed using Spectrum cable modem than I would with AT&T. So that's pretty bad, right? And that has to do with how the technology works. Slower than cable modem. Now, cable modem, the early cable modems were actually somewhat problematic because they were only one directional. So you would actually have to have a telephone line and a cable modem, because you would download over the cable modem, but you would use the telephone line to send your request. So because you couldn't send a request through the coaxial cable, you can only receive on the coaxial cable. So you actually had to have 2 different pieces of equipment to use early cable modems. You'd have a normal modem to send your request, but then instead of downloading at 56 kilobits, you maybe would have been able to download at, maybe call it 10 megabits per second. Some of the earlier ones were maybe something like that. Much faster than maybe even 3 megabits per second, but much faster than dial-up. All right. But these guys, let's just say once we got past that thing of having to have the phone line, you can do 2-way communication over the cable modem. Much faster. All right, so DSL was dedicated bandwidth, so it was not shared with your neighbors and stuff. Where cable modem had a much faster speed capability, but technically your bandwidth was shared with the other people in your neighborhood. All right, so what does that mean? Well, this becomes a little bit of an interesting story in that let's assume that you had 50 megabit per second cable modem service, and there were 10 people who lived in your neighborhood who all had the same cable service. So technically, if all of you were maxing out your internet connection at the same time, you would be using 500 megabits per second of bandwidth. Well, let's say that the cable company only was able to give you 200 megabits per second internet to your neighborhood. Well, so now, even though you're paying for 50 megabits per second per household, and all the households just happen to be trying to use their maximum internet at the same time, they're not going to be able to, because there's only 200 megabits of per second of internet to go around. All right, so they're not going to get the peak performance on their connection. All right, so even though they paid for something capable of up to 200 megabits, they're only going to get what they are able to get in terms of their neighborhood. And that's all being, potentially squelched by wherever they're downloading from. So just because they can download it 50 megabits per second, their download is somebody else's upload. So if the place they're trying to download this stuff from can only give it to them at 2 megabits per second, doesn't matter how fast their modem is, they're only going to ever get it at 2 megabits per second maximum. All right. So that's the cable modem technology, is a shared technology. DSL is not shared, it's dedicated, but it's a little bit complicated even with that, because they would follow the model similar to like hotels. I don't know if any of you have experienced this before on either airlines or hotels, where you booked a flight or you made a reservation at a hotel and you showed up and they said that you didn't have a seat, they didn't have a room for you. Well, I made a reservation, or I bought a ticket. Well, what airlines and hotels do is they overbook the flight, they overbook the hotel with the expectation that a certain number of people are not going to show up or going to cancel, so that the flight or the hotel will be able to be as full as possible. And then the risk that they're taking is that they might have to give somebody a free flight voucher or give them a free hotel room or something like that at a different place. They might have to do some sort of alternative in order to accomplish it. So with that in mind, AT&T, even though they were saying, okay, your 3 megabits per second is yours, you don't have to share it with your neighbor. Well, if they only have 30 megabits per second to go around, and they sold 60 megabits per second worth of internet, they still need to hope that more than 10 of their customers don't try to maximize their connection at the same time, because they don't have enough rooms. They don't have enough bandwidth to go around. Even though it's not shared, they're not going to be able to deliver. All right, so they both kind of suffer from some version of that problem. All right, so we talked about that. Probably don't need that slide. Okay, so we'll pick up here next time at the NAT. Again, go ahead, and if you still do not have access, I know we got a bunch more people registered for class just yesterday. So go on to my.cuw.edu and see if you have access to Blackboard. Click on student and you should see Blackboard there. But if you don't still have access to Blackboard, message me just so I can kind of keep tabs on who's in and who's not. Otherwise, remember, homework is due by midnight on Sunday. I've emailed the people who don't have access to the assignment. The rest of you, the assignment should be on Unit 3 on Blackboard. I will see everybody on Monday. So any
Doc-
questions, comments, concerns, bribes?
One question, Dr. Rahman. This is Syed Moinuddin. I
Yep,
want
go
to
ahead.
ask about the discussion forum, which is there on the Blackboard. Is it mandatory to do it, or what do you suggest?
I would suggest you do it, but I'm not going to make it mandatory.
So let me rephrase it. Does it?
It's not going to,
influence-
I'm not going to let it affect your grade.
Okay.
But I would suggest that you do it, because then you are kind of making sure you're, collaborating with your other students.
Makes sense.
Getting to know people, talking to them on Slack. I mean, I know the international community is fairly tight knit anyways, but I'm sure not all of you are buddy with everyone else. And keep in mind that you're all going to be going through this program together. So, getting to know people who aren't just in your immediate friend group and stuff, I think is beneficial, but I'm not going to grade that just because of the nature of this class being a face-to-face class, but we're using the online content.
Sure.
Sound good?
Thank you. All good.
Yeah, Dr. Richmond, this is Swadeep.
Sure.
So I got an access to the Blackboard, but I'm facing some problems in registering the classes. So I emailed you regarding this yesterday.
Yeah, and didn't I connect you? I
Yeah,
did that for a bunch of people yesterday. What's your name again?
Swadeep.
What's your email address?
Oh, Swadeep Yadav .eligala.
All right, I got it. Yeah, I replied back at 2:51 p.m. yesterday to you and Megan Wolf. So you should get email from me at 2:51 p.m. yesterday, right?
Yeah, I received this email, but what's my next step to do actually?
Well, Megan should get you registered, but if you want, go ahead and reply all to that, because Megan's the one who will actually register you for the class. So reply all, and maybe ask Megan if there's anything else you need to do, because she can do it pretty quickly. So my guess is, I mean, if you go on to Blackboard, do you see 540?
Oh, 1 minute. Give me a minute.
Yeah.
Yeah, in the Black